Hello everyone, my name is Bai Sittie Jahara C. Mohammad from Bachelor of Secondary Education major in Science 1B. Today, I will be discussing the relative dating and the absolute dating. So firstly, what is dating? So dating is not a word that you might think of, but it is when geologists date rocks, they are determining how long they are formed. So it means that dating is a method used by geologists or archaeologists when they want to know the age of rock, fossil, or artifacts and how long they are formed. So in dating, there are two ways to do this, which is the relative dating and the absolute dating. So let us know the difference between these two dating. So what is relative dating? Relative dating estimates whether an object is younger or older than other things found at the site. Relative dating does not offer specific dates. It simply allows to determine if one artifact, fossil, or stratigraphic layer is older than the other. In relative dating, it doesn't really offer specific dates or years in determining how long they are formed, but it only determines if this stratigraphic layer or this rock is older than the other. Next, what is absolute dating? Absolute dating provides more specific origin dates and time ranges, such as an age range in years. How specific these dates can be will depend on what method is used. In absolute dating, we can actually date rocks in years, and we can actually know how long they are formed this rock or the fossil is. So to make it understandable, relative age or date is order in which events occurred, and in absolute dating refers to the age in years. So here we have the Venn diagram. In relative dating, it uses stratigraphic methods and it is a qualitative method of dating. While in absolute dating, it uses a radiometric methods and it is a quantitative method of dating. So here is the example in sentence. Relative dating, the tribolite fossil is older than the dinosaur fossil tooth. While in absolute dating, the tribolite fossils is 489 million years old. So we can actually see here the difference because in relative dating, we just compare who is the older, and in absolute dating, we actually provide an age or years. There are 5 principles of relative dating. Let's start with the principle of superposition. Principle of superposition. The principle was formulated in the 17th century by the Danish scientist Nicolas Stefano. It states that each layer of sediments is piled on top of another layer, making the one on top of the strata the youngest one, while the layer at the bottom of the strata as the oldest. So basically, in principle of superposition, it states that the bottom layer of the sediments is the oldest. So while the sediments that piled on top are actually the youngest. So here is the example of principle of superposition, the Grand Canyon. We can actually see here in this picture, the bottom is the oldest and the top is the youngest. Number 2 is the principle of original horizontality. It was proposed by Danish geological Nicolas Stefano, 1633 to 1686. Layers of sediments are originally deposited horizontally. Those strata that found not in horizontal order may have been deformed by the movement of the Earth's crust. So, these sediments are originally horizontal, but it's because of the Earth's movement, like earthquake or something natural occurring, these sediments are now not in horizontal. Number 3 is the principle of cross-cutting. It was originally developed by James Newton and elaborated by Charles Lyell. It states that an igneous intrusion is always younger than the rock it cuts across. In principle of cross-cutting, we have actually different types of it. So, these are the structural, stratigraphic, sedimentological, paleontologic, and geomorphic. So the first one is structural. A fault or structure cuts through an older rock. Number 2, stratigraphic. An erosional surface cuts across older rock layers, geological structure, or other geological features. Number 3 is sedimentological. It occurs when currents have eroded or scored older sediments in a local area to produce, for example, a channel filled with sand. That is an example of sedimentological. While in fourth is paleontology. It occurs where the animal activity or plant growth produces truncation. This happened, for example, where animal burrows penetrate into pre-existing sedimentary deposits. So in number 5, this is the geomorphic. It occurs where a sacrificial feature, such as a river, flows through a gap in a ridge or rock. In similar example, an impact crater excavates into a subsurface layer of rock. So those are the different types of principle of cross-cutting. So in number 4 of principle of relative dating, we have the principle of inclusion. It states that any rock fragments that are included in a rock must be older than the rock in which they are included. So, example here in this picture, the pebble in this conglomerate are older than the conglomerate itself. So, the last principle of relative dating, we have the principle of unconformities. It is a contact between two rock units when the upper unit is usually much younger than the lower unit. An unconformity represents time during no sediments were preserved in a region. The interval of geological time not represented is called hiatus. So here we have actually different types of unconformities. So let us first discuss the angular unconformities. So it is an unconformity. Horizontal parallel strata of sedimentary rock are deposited on tilted and eroded layers, producing an angular discordance with the overlying horizontal layers. Next is buttress unconformities. Is when younger bedding is deposited against an older strata, thus influencing its bedding structure. Next is disconformity. It is an unconformity between a parallel layers of sedimentary rocks which represents period of erosion or non-deposition. These conformities are marked by future by several erosion. Next is non-conformity. It exists between sedimentary rocks and metamorphic or igneous rocks. When sedimentary rocks lies above and was deposited on the pre-existing and eroded metamorphic or igneous rock. So the last one is the paraconformity. It's a type of unconformity in which strata are parallel. There is a little apparent erosion and the unconformity surface resembles a simple bedding plane. It is also called non-depositional unconformity or pseudoconformity. So that is the different types of principle of non-conformities. So we are in next method of dating rocks, which is the dating with radioactivity. So remember, in absolute dating, the commonly used dating method here is the radioactive dating. So let us first know what is this radioactivity. Radioactivity is the sudden disintegration, decay of an unstable nucleus leading to energy release and loss of nucleus particles. So usually the protons and neutrons are usually strong enough to bind together, but in some isotopes the nuclei is unstable. This is because of the protons and neutrons are not strong enough to bind together. So in result is the nuclei starts decaying or starts to disintegrate, and this process is called radioactivity. Next is what is radiometric dating. Radiometric dating, or is also called radioisotope dating or radioactive dating, is defined as a method used to establish how old an object is by measuring the amount of radioisotope the object contains against the decay product it contains. So radiometric dating, or also known as radioactive dating, this technique or this method is used to determine how old the rock is, and this technique is usually based on comparison between the observed abundance of natural occurring radioactive isotope and its decay products using known decay rates. So before we can really understand this radiometric dating, we first must know what is this isotope. So isotope is atoms of the same element, same number of protons, but with different number of neutrons. So we all know that the protons, the number of protons in an atom, determines the identity of an element. So we have the picture right here, the nuclei of 3 isotopes of hydrogen. So the first one here is the hydrogen. It has a number of 1 proton. The deuterium and the tritium are all hydrogen, but the difference here is the neutrons. So the hydrogen and the deuterium have a 1 neutron, while the tritium have a 2 neutrons. So the stable here is the hydrogen, while the unstable here is the tritium. Radiometric dating via radioactive decay process. Radiation is given off from a process called radioactive decay. Radioactive decay occurs when the original nucleus or parent nucleus of an unstable atom decomposes and forms a different nucleus or the daughter nucleus. So as I said before, the nuclei or the nucleus is seems to happy with the protons or neutrons. So sometimes some isotopes or some nucleus wants to get rid of some or change some or add some of this. So the result is it's decaying into a different isotope. So we have the picture right here. The parent nucleus, it's decaying into daughter nucleus. Of course, not all isotopes are decaying. For example, right here is we have the carbon-12, 6 proton and 6 neutrons. And carbon-13, we have the 6 protons and 7 neutrons. And in carbon-14, we have the 6 protons and 8 neutrons. So you can actually see here that these elements have 6 protons, and the only thing that difference between these 3 are the neutrons. So in carbon-12 and carbon-13, these are the stable neutrons, or not neutrons. This is the stable isotope. While the carbon-14, this is the unstable, which is it's decaying. So we have 3 common types of radioactive decay, which is the alpha decay, beta decay, and beta capture. So what is alpha decay? Alpha decay, or emission of alpha particles from the nucleus. This is the loss of alpha particles, 2 protons and 2 neutrons, equals helium ion. So here is yung parent isotope or yung parent nucleus is naglolo siya ng 2 protons and 2 neutrons or helium, because anything that has a 2 protons is helium, right? Example natin dito is yung uranium-238-92. So remember, yung 238 is ito na, yung upper number is ito na yung neutrons and protons, while yung nasa babang number is ito yung protons. So uranium-238 decays into thorium-234. So we can actually see here in these numbers na nag-loss sila ng dalawang protons and ng dalawang neutrons. That's why naging thorium-234 na siya. Next is beta decay or emission of beta particle electron from the nucleus. This is the loss of beta particles, negative charge particle emitted, turning neutron in a proton. So in beta decay, this happens in the process of carbon-14 decays into nitrogen-14. So here we are not losing anything. It's just that yung neutron nagiging proton siya. So as you can see here, yung upper number ng carbon and nitrogen didn't change, but yung proton niya is nag-add up. Because yung neutron nga ng carbon naging proton na siya. That's why nag-change yung isotope na carbon into nitrogen-14. Next is beta capture. Beta capture or capture of electrons by the nucleus. Gain beta particles, negative charge particle, captured, turning proton into neutron. So here in beta capture, this is the opposite of beta decay, because the nucleus is going to capture a negative charge particle, turning a proton into neutron. We all know that the proton is positively charged. So if it gets some of negative charge, it will become neutral. In terms of potassium-40, it decays into argon-40. As you can see in this picture, it nag-lower yung number of protons sa argon-40. So let us proceed to another method used by radiometric dating, which is the half-life. So half-life, it is the time taken for the radioactivity of a specified isotope to return to half of its original value. So we have the parent material of parent isotope, unstable isotope, radioactive, and the daughter material, which is the stable element or decay product. So the example of half-life is the carbon-14. So we all know that the carbon-14 is the unstable isotope. So we have here the example, carbon-14 among the animals. So parent material. So pagka death niya or freshly death pa lang niya is 100% siya. 100% pa lang ito, right? So after ng half-life, magiging 50%. And second half-life niya naman is magiging 25%. And third half-life naman niya is magiging 12.5%. Another half-life na naman, which is the fourth half-life na naman, magiging 6.25%. So, in carbon-14, it's just, ang number of half-lives naman niya is equivalent to one half-life is equivalent to 500-730 years. So here we have the common radioactive isotopes used to date rocks. So we have the carbon-14, potassium-40, rubidium-87, uranium-238, or uranium-235. So in carbon-14, this is usually a organic material, and the rest is the best in dating rocks, such as igneous rocks, metamorphic rock, or sedimentary rock are not really the best to date. Okay, so ang half-life niya, the equivalent half-life is In carbon-14, we have 5,730. And in potassium-40, we have 1.3 billion. And in rubidium-87, we have 47 billion. And uranium-38 is 4.5 billion. And uranium-235, we have 710 million. So remember, this half-life is really useful to determine the age of rocks. So let us remember in radiometric dating or radioactive dating na meron ito siyang parent isotope, which is ito yung mga unstable isotope na nagde-decay sila into more stable daughter isotope, which is why we have a example of carbon-14 that decays into nitrogen-14, because carbon-14 is unstable isotope and the nitrogen-14 is the stable isotope. That's why we must also remember na yung parent isotope, yung element niya is mag-iiba siya sa daughter isotope niya because it has a different number of protons. And also remember, in this radiometric dating is meron siyang equivalent of years. That's why in absolute dating, the common used method in dating is radiometric dating. So, paano nga ba natin ma-identify yung age of rocks by using this method? So, dapat i-identify natin kung ilan nga ba yung carbon-14 ng nilalaman ng fossil na yun. So, example, yung fossil na yun is meron siyang 6.25 carbon-14. And yung carbon-14 half-life is equivalent to 5,730 years. So, 4 na half-life yung nangyari dun sa fossil na yon. And 4 times 5,720 years is equivalent to the age of the fossil. So we can actually see here in this picture we have rocks. So the newly formed rocks is the blue dots or the parent isotope, which is the uranium. So as the time goes by, it decays into more stable daughter isotope, which is the blue dots, which means this is the lead. So the uranium parent isotope decays into more stable daughter isotope, which is the lead. Thus explains the radiometric dating of rocks. That's all for this video. I hope you learned something. I know this video is really complicated, so if you have a question or clarification, please just message me, and I hope you learned something. So thank you for watching. Goodbye.